Hi and welcome back to freesciencelessons.co.uk. By the end of this video, you should be able to describe early ideas of the structure of atoms. We call this the Plum-pudding model. You should then be able to describe the alpha scattering experiment, which was used to work out the nuclear model of atomic structure, which is the currently accepted model. Now, we use the word atoms a lot in science, but this idea has been around for a long time. Thousands of years ago, the ancient Greeks believed that everything's made of atoms. They believed that atoms are tiny spheres which cannot be divided, and that idea was accepted for hundreds of years. However, in 1897, scientists discovered that atoms contain tiny negative particles. They called these electrons. Now, that was a big discovery because it showed that atoms are not tiny spheres that cannot be divided. Atoms must have an internal structure. Scientists now suggested a different model for the structure of atoms. They called this the Plum-pudding model. The Plum-pudding model suggested that an atom is a ball of positive charge with negative electrons embedded in it. So I'm showing you here the Plum-pudding model. You can see that we've got a ball of positive charge, and embedded in it we've got negative electrons. This is what an actual plum pudding looks like, so you can see where the name came from. Now, scientists wanted to know if the Plum-pudding model was correct. To find this out, they carried out an experiment. We call this the alpha scattering experiment, and you need to be able to describe it. The alpha scattering experiment is one of the most important experiments in science because it radically changed the way that we think about atoms. First, the scientists took a piece of gold foil, like this one here. The reason that they used gold is that we can hammer gold out into very thin foil, just a few atoms thick. Scientists then fired tiny particles at the gold. We call these alpha particles, and you'll find out more about these when you study physics. The key fact is that alpha particles have got a positive charge. The first thing they noticed was that most of the alpha particles simply passed straight through the gold foil without changing direction, just like this. Sometimes though, an alpha particle was deflected. In other words, it changed its direction as it passes through the gold foil, like this. And sometimes an alpha particle simply bounced straight back off the gold foil, like this. So let's look at what scientists worked out from these results. The fact that most of the alpha particles went straight through the gold foil told the scientists that atoms are mainly empty space. So straight away they knew that the Plum-pudding model had to be wrong. Secondly, because some of the alpha particles were deflected, that told the scientists that the centre of the atom must have a positive charge. Alpha particles are come close to this are repelled and they change direction. And finally, because alpha particles sometimes bounce straight back, that told the scientists that the centre of the atom must contain a great deal of mass. We now call the central part of an atom the nucleus. When an alpha particle collides directly with the nucleus, it simply bounces back in the original direction. So from these results, scientists replaced the Plum-pudding model with the nuclear model, and I'm showing you that here. So most of the atom is simply empty space. In the centre, we've got a tiny positive nucleus, and around the edge, we've got negative electrons. If we go back to the alpha scattering experiment, we can see that most of the alpha particles pass straight through because most of the atom is empty space. Some of the alpha particles are deflected as they pass very close to the positive nucleus and are repelled, and some of the alpha particles directly strike the nucleus and are repelled straight back. This tells us that the nucleus contains most of the mass of the atom. So as you can see, new experimental evidence led to the Plum-pudding model being replaced by the nuclear model. Remember, you'll find lots of questions on this topic in my revision workbook, which you can get by clicking on the link above. In the next video, we're going to look in more detail at the nuclear model of atomic structure.